The night sky has always been humanity's oldest canvas of mystery. For millennia, we gazed upward, charting the predictable dance of celestial bodies, finding comfort in their regularity. But on September 13, 2024, that comfort shattered. Astronomers detected something that should not exist. Something that defies our understanding of how the cosmos operates. Its designation is 3I/Atlas, the third confirmed interstellar visitor to our solar system. And unlike its predecessors, this object is behaving in ways that keep scientists awake at night. The discovery came from the Atlas Survey System in Hawaii, an automated network of telescopes designed to scan the heavens for near-Earth asteroids. What they found instead was an object moving at 78 kilometers per second relative to the Sun. That velocity alone marked it as special. Nothing born in our solar system moves that fast unless something catastrophic propelled it. The trajectory calculations came back within hours, and the results were unambiguous. This visitor originated from somewhere beyond our Sun's gravitational embrace. Somewhere in the vast darkness between stars. At first, 3I/Atlas appeared to be a straightforward interstellar comet. Spectroscopic analysis revealed ice. Water ice. Carbon dioxide ice. The expected chemical signatures of a body formed in the outer reaches of another star system. But then the anomalies began. Temperature readings fluctuated in patterns that made no sense for a simple ball of ice and rock. The object's brightness varied irregularly, suggesting either a highly unusual rotation or changes in its surface properties. Most disturbing of all, its outgassing behavior defied standard comet models. When comets approach the Sun, they heat up. Ice sublimates directly into gas, creating the characteristic tail we associate with these cosmic wanderers. The process is predictable, governed by straightforward physics. Solar radiation hits the surface, energy transfers, ice transforms to vapor. We can calculate this with precision. But 3I/Atlas released gas in bursts that didn't correlate with its distance from the Sun. It brightened when it should have dimmed. It accelerated when thermal models predicted deceleration. Something else was happening. Something we don't understand. The scientific community initially approached these anomalies with cautious optimism. Perhaps the object had an unusual composition. Maybe its rotation axis created thermal asymmetries we hadn't accounted for. Ice pockets beneath the surface might be releasing gas in delayed reactions to heating that occurred days or weeks earlier. These explanations made sense. They fit within our established framework of cometary physics. But as weeks turned to months, and more data accumulated, these conventional explanations crumbled under scrutiny. Radio telescopes around the world turned their dishes toward 3I/Atlas. SETI, the search for extraterrestrial intelligence, activated its most sensitive receivers. If this object were artificial, if it carried technology, we would detect electromagnetic emissions. The Breakthrough Listen initiative, funded by tech billionaires specifically to search for alien signals, devoted significant observation time to this mysterious visitor. They found nothing. No radio signals. No laser pulses. No obvious signs of technology. But absence of evidence is not evidence of absence. The object's trajectory took it through the inner solar system at an angle 43 degrees above the ecliptic plane. This path brought it no closer than 2 astronomical units from Earth, roughly twice the distance between our planet and the Sun, close enough to study with powerful telescopes, but far enough to provide no immediate threat. Or so we thought. Because when researchers back-calculated 3I/Atlas's origin vector, projecting its path backward through space and time, they made a discovery that changed everything. The object came from the direction of Vega. Not exactly from Vega, but close enough that the coincidence seemed impossible to ignore. Vega, the bright blue star in the constellation Lyra, lies just 25 light-years from Earth. In cosmic terms, that's our neighborhood. And Vega is known to possess a debris disk, the scattered remnants of planetary formation, possibly even mature planets. If intelligent life exists anywhere within our local stellar vicinity, Vega is among the most likely candidates. But here's where the story becomes genuinely unsettling. When scientists refined their trajectory analysis, Accounting for gravitational perturbations from Jupiter and Saturn, they realized 3I/Atlas didn't simply pass through our solar system randomly. Its path, if extended forward, would bring it perilously close to Earth's orbit in exactly 7 years, 4 months, and 11 days. The object would cross the precise point in space where Earth will be on January 24, 2032. The margin of error in these calculations is substantial. Space is vast, and small uncertainties in velocity measurements accumulate dramatically over years of travel. But the central projection is clear. 3I/Atlas will pass through Earth's orbital path. Whether Earth and 3I/Atlas occupy the same point in space at the same moment depends on factors we can't yet measure with sufficient precision. The probability of collision stands at approximately 1 in 23,000. Those seem like comfortable odds. But consider this. 1 in 23,000 is roughly the same probability as drawing a specific card from a deck shuffled 10 times. Not impossible. Not even particularly unlikely when you consider how many objects pass through the inner solar system. But for an interstellar object, following a trajectory that originated from a star system with potential for life, the coincidence defies comfortable probability. Some researchers immediately declared the convergence pure chance. The universe is old and vast, they argued. Improbable events happen constantly simply because there are so many opportunities for them to occur. But others weren't so sure. Because the anomalies surrounding 3I/Atlas extended beyond its trajectory. Deep imaging studies revealed something extraordinary about the object's surface. In high-resolution photographs taken by the Hubble Space Telescope and the James Webb Space Telescope, analysts detected patterns. Geometric patterns. Lines and curves that appeared artificial, though at the extreme limits of what our instruments could resolve. These features measured less than 100 meters across, barely visible even with our most powerful optics. The patterns could be natural. Stress fractures in ice. Layered deposits of different materials. Coincidental arrangements of debris. Nature creates apparent order from chaos all the time. We see faces in clouds, animals in rock formations. Our brains are wired to detect patterns, even where none exist. But these patterns on 3I/Atlas displayed characteristics that troubled experts. They showed bilateral symmetry. They repeated at regular intervals across the object's surface. And in several locations, they formed what appeared to be right angles. Nature produces right angles occasionally, through crystalline structures or perpendicular fracture planes. But multiple right angles, arrayed in symmetrical patterns across an object's surface, push the boundaries of natural formation into the realm of the statistically improbable. NASA convened a classified panel to assess the situation. The meeting brought together astronomers, physicists, planetary scientists, and representatives from the intelligence community. What they discussed remains officially secret, but leaks have emerged. According to anonymous sources, the panel evaluated 3 scenarios, each more disturbing than the last. Scenario 1. Natural object, unusual but explicable by physics we understand. This remained the consensus view among most scientists. The universe is weird. Quantum mechanics is weird. Astrophysics is full of phenomena that seem impossible until we understand them. Black holes. Neutron stars. Fast radio bursts. Each of these seemed to violate natural law until we developed frameworks to explain them. Perhaps 3I/Atlas simply represents another cosmic oddity, a comet with properties we haven't encountered before. Scenario 2. Derelict artificial object. Abandoned technology from a long-dead civilization. This scenario gained traction among some researchers, particularly those who studied Oumuamua and Borisov, the first 2 confirmed interstellar visitors. If space is full of debris from extinct civilizations, the occasional artifact might wander into our solar system. The object's anomalous behavior could result from ancient systems degrading, releasing stored energy in unpredictable ways. The geometric patterns could be remnants of construction or design. And the trajectory toward Earth's orbit might be pure coincidence, or the result of gravitational interactions with planets in its home system billions of years ago. Scenario 3. Active probe, intentionally directed to Earth, possibly hostile. This was the nightmare scenario, the one that kept the intelligence community representatives in that classified meeting taking detailed notes. If an alien civilization detected Earth's technosignatures, our radio and television broadcasts leaking into space for the past century, they might send a probe to investigate. Or worse, to preemptively neutralize a potential future threat. The trajectory convergence, the unusual thermal behavior, the geometric surface patterns, all could indicate active guidance systems. The object might be observing us right now, transmitting data back to its creators, preparing for an encounter in 2032. The panel officially concluded that Scenario 1 remained most likely. But they recommended continued intensive monitoring. Multiple space agencies now track 3I/Atlas daily. Every major telescope network includes it in regular observation schedules. And quietly, very quietly, contingency plans are being developed. Here's what we know with certainty about 3I/Atlas as of today. The object measures approximately 400 meters in length and 150 meters in width, making it roughly cigar-shaped, similar to Oumuamua but larger. Its surface reflects only 4% of incident sunlight, making it one of the darkest objects ever observed in our solar system. Spectroscopic analysis confirms the presence of water ice, carbon dioxide, and trace amounts of organic compounds including amino acids. The object rotates once every 8.3 hours, but this rotation shows irregularities suggesting either internal mass redistribution or active stabilization. Most intriguingly, sensitive infrared detectors have measured localized hot spots on the object's surface. These areas maintain temperatures approximately 15 degrees Celsius higher than surrounding regions, despite receiving identical solar radiation. The heat appears to originate from within the object itself. Radioactive decay could explain this, but the isotopes required would need to be present in concentrations far higher than seen in any natural body. Alternatively, chemical reactions between different ices might generate heat, though no known reaction produces the observed thermal signature. The European Space Agency proposed a mission to 3I/Atlas in late 2024. The plan involved launching a fast probe equipped with cameras, spectrometers, and radar systems that would intercept the object before it exits the inner solar system. The mission would answer definitively whether 3I/Atlas is natural or artificial. But funding proved impossible to secure in the necessary timeframe. Private companies showed interest, particularly those owned by space enthusiast billionaires, but technical challenges proved insurmountable. The launch window closed in March 2025. We missed our chance for a close encounter. Now 3I/Atlas races outward, accelerating as it falls down the sun's gravity well, heading back into the darkness between stars. Or so it appears. Because here's where the story takes its most disturbing turn. In June 2025, astronomers noticed something impossible. The object's velocity was changing. Not the smooth, predictable change caused by solar gravity, but small, rapid alterations in speed and direction. These delta-v events, as they're called, suggested thrust. Propulsion. Something was pushing 3I/Atlas, altering its course by tiny amounts. Natural outgassing could theoretically cause such effects. When comets release jets of gas from one side, they experience rocket-like acceleration. But the timing and magnitude of 3I/Atlas's velocity changes didn't match outgassing patterns observed through telescopes. The thrust events occurred when no visible outgassing was detected, and they always pushed in directions that kept the object on its projected course toward Earth's orbital crossing point in 2032. The implications are staggering. If 3I/Atlas can alter its velocity, it's not simply coasting through space on a ballistic trajectory. It's navigating, steering, maintaining a precise course toward a predetermined destination. The small corrections observed so far total only a few meters per second of velocity change, but they're enough to compensate for gravitational perturbations from Jupiter and Saturn that would otherwise have pulled the object off course. Statistical analysis by independent researchers calculated the probability that random outgassing events would coincidentally correct the object's trajectory in exactly the right direction and magnitude to maintain course toward Earth's orbit. The number was vanishingly small. 1 in several billion. Not impossible, but so unlikely that alternative explanations deserve serious consideration. Dr. Abraham Loeb, the controversial Harvard astronomer who argued that Oumuamua might be artificial, published a paper analyzing 3I/Atlas in August 2025. His conclusion was unequivocal. The object exhibits signs of directed motion inconsistent with natural processes. Whether this indicates intelligent design or simply unusual physics remains unclear, but dismissing the artificial hypothesis out of hand is scientifically unjustifiable. The paper ignited fierce debate within the astronomical community. Critics accused Loeb of sensationalism, of seeing aliens in every unusual observation. Supporters pointed to the accumulating evidence that defied conventional explanation. The truth is, we don't know. And that uncertainty is perhaps the most frightening aspect of this entire situation. Because while scientists debate and analyze, 3I/Atlas continues its journey. Every day it travels 6.7 million kilometers. Every week it puts another 47 million kilometers between itself and our instruments. By the end of 2025, it will be too distant for detailed observation by any telescope currently operational. We'll track its position, measure its trajectory, but we won't see its surface. Won't detect its thermal emissions. Won't know if those geometric patterns are growing, changing, or activating. And then we wait. 7 years? Until January 2032, when 3I/Atlas returns. When it crosses Earth's orbital path. When we discover whether that 1 in 23,000 probability was just a number on a page, or a countdown to an encounter that changes everything. But here's what keeps a certain subset of researchers awake at night: the scientists who specialize in worst-case scenarios, the military strategists who plan for improbable threats. What if 3I/Atlas isn't alone? What if it's a scout, a reconnaissance probe sent ahead of something larger? Interstellar travel is hard. Impossibly hard by our current understanding. The distances are vast beyond human comprehension. The nearest star, Proxima Centauri, lies 4.24 light-years away. At our fastest current spacecraft speed, reaching it would take 70,000 years. Any civilization capable of crossing such distances would need technology far beyond ours. But they would also need intelligence, strategy, planning. An intelligent strategist sends scouts before committing resources to unknown territory. They observe before acting. They assess threats before engaging. If 3I/Atlas is such a scout, its mission might be simple surveillance. Gather data. Analyze Earth's technological development. Report findings. Or its mission might be more sinister. Test our detection capabilities. Map our defensive systems. Prepare the way for something larger. The Chinese government reportedly ordered increased funding for space-based defensive systems in late 2024, officially justified as asteroid protection infrastructure. Russia quietly accelerated development of its nuclear-powered space tug, a system theoretically designed to deflect hazardous asteroids. The United States Space Force, often ridiculed as a solution looking for a problem, suddenly found its budget priorities shifting toward long-range detection and tracking capabilities. None of these governments cited 3I/Atlas specifically. But the timing suggests coordination, shared intelligence, quiet acknowledgement that something requires preparation. When world powers agree on anything, let alone agree silently and without public announcement, it indicates serious concern at the highest levels of decision-making. Meanwhile, private observatories and amateur astronomers continue monitoring 3I/Atlas independently. The data gets posted to open-access databases, analyzed by researchers worldwide, debated in forums and conferences. This democratic approach to science means we'll likely know if something changes, if the object does anything unusual before reaching Earth's orbit. But it also means we'll all know simultaneously. No government could keep such information secret. The panic that might ensue from definitive proof of alien intelligence approaching Earth is difficult to predict, but few models suggest a calm, rational response from global populations. Consider how humanity reacted to the COVID-19 pandemic. A visible, Measurable threat that killed millions, yet societies fractured over how to respond. Conspiracy theories flourished. Leadership failed. Cooperation between nations crumbled. Now imagine announcing that an alien object, possibly artificial, possibly hostile, is heading toward Earth. The social disruption could be catastrophic even if the object itself poses no actual danger. This is why official statements from space agencies remain carefully noncommittal. 3I/Atlas is described as an unusual interstellar comet worthy of continued study. The geometric patterns are acknowledged but characterized as ambiguous. The trajectory convergence is noted, but the collision probability is emphasized as extremely low. Nobody in authority is willing to say the words that would unleash global panic. Nobody wants to be wrong. But equally, nobody wants to be remembered as the person who failed to warn humanity of an approaching existential threat. Let's examine what we know about interstellar travel and why it matters for understanding 3I/Atlas. The physics are brutal. Space between stars isn't empty. It contains an extremely thin scattering of atoms, mostly hydrogen, along with dust particles and the occasional molecule. At normal speeds, this presents no problem. But accelerate to even 10% the speed of light, and these sparse atoms become deadly radiation. Each hydrogen atom you collide with at relativistic speeds impacts with energy equivalent to a small bomb. The cumulative radiation dose would be lethal to any biological organism and destructive to most electronic systems. This means any interstellar spacecraft needs shielding. Substantial shielding. Perhaps kilometers of ice or rock at the bow, acting as armor against the interstellar medium. And what does 3I/Atlas look like? A 400-meter elongated object with a very dark surface and a composition rich in ice. Exactly what you'd expect from a shielded interstellar probe. But the speed is wrong. 3I/Atlas travels at 78 kilometers per second, just 0.026% the speed of light. At that velocity, crossing the 25 light-years from Vega takes nearly 100,000 years. Why would any civilization build a probe that requires 100 millennia to reach its destination? By the time it arrives, the civilization that launched it might be extinct. The stars themselves will have moved. The target system might have changed dramatically. Unless time doesn't matter. If you're a civilization with million-year planning horizons, if you've solved the problems of social cohesion and technological stagnation that plague shorter-lived cultures, then century-long voyages become acceptable. Or perhaps the probe carries self-replicating technology, von Neumann machines that can harvest resources, build copies of themselves, and continue exploring indefinitely. Launch one probe. And in a few million years, your descendants cover the galaxy through exponential replication. Or maybe, just maybe, the slow speed is intentional. A test. Send a probe slowly enough that the target civilization has time to detect it, analyze it, respond. Gauge their technological level by how they react. If they can alter its course or destroy it, they're sufficiently advanced to warrant caution or respect. If they can only observe helplessly, they pose no threat. Earth falls into that second category. We detected 3I/Atlas. We analyzed it. We even proposed a mission to intercept it, though that mission never launched. But we cannot alter its course. Cannot board it. Cannot stop it. We are technologically incapable of doing anything except watching and waiting. And perhaps that's the point. There's another possibility that deserves consideration, though it edges into territory that makes many scientists uncomfortable. What if 3I/Atlas is neither natural nor artificial, but something in between? Life exists on a spectrum. Viruses blur the line between living and non-living. Crystals grow and replicate in patterns that seem almost alive. We've discovered organic molecules in interstellar space, complex carbon chains that form spontaneously in the cold darkness. What if intelligence exists in forms we haven't imagined? What if consciousness can emerge in structures that aren't biological? Arthur C. Clarke wrote, "Any sufficiently advanced technology is indistinguishable from magic." But perhaps there's a corollary. Any sufficiently advanced life is indistinguishable from technology. An organism evolved or engineered for interstellar travel might resemble a spacecraft to our instruments, while being fundamentally biological. 3I/Atlas's unusual thermal properties, its geometric surface patterns, its apparent ability to navigate, all could indicate a living system rather than a constructed machine. This sounds like science fiction, but consider Earth's own extremophiles. Organisms living in boiling acidic pools. Bacteria surviving cosmic radiation doses that would instantly kill humans. Tardigrades entering suspended animation for decades and reviving when conditions improve. Life adapts to fill every available niche. Why assume it stops at planetary boundaries? The amino acids detected on 3I/Atlas's surface are particularly intriguing in this context. Amino acids are the building blocks of proteins, the molecular machinery of terrestrial life. Their presence on an interstellar object could be contamination from Earth, though the object never approached closer than 2 astronomical units. Could be random chemistry, organic molecules forming through non-biological processes. Or could be evidence that 3I/Atlas carries life, either fossilized remnants from its ancient past or active organisms still viable after their long journey through the void. We won't know unless we sample it directly. And we won't get that chance until 2032. Let me take you through what will happen when 3I/Atlas reaches its closest approach to Earth's orbit. The date is January 24, 2032, approximately 2:47 a.m. Universal Time. Earth will be at a specific point in its orbit, roughly 149.6 million kilometers from the Sun. 3I/Atlas will cross that same orbital path, but not necessarily at the same instant. Current models project the object will pass through Earth's orbital plane approximately 17 hours before Earth reaches that point. 17 hours. In cosmic terms, that's simultaneous. In practical terms, it means we miss collision by about 105 million kilometers as Earth continues its journey around the Sun. But those calculations assume 3I/Atlas continues on its current trajectory without further velocity changes. If the object can navigate, if those thrust events continue, 17 hours is plenty of time for course corrections. A velocity change of just a few hundred meters per second, applied at the right moment, could put 3I/Atlas on a collision course with Earth. The energy required is minimal by spacecraft standards. A small rocket motor firing for a few minutes would suffice. Of course, this assumes hostile intent. Why would an alien probe want to collide with Earth? The answer is darkly simple. Kinetic impact. 3I/Atlas mass is roughly 10 billion kilograms. At its velocity of 78 kilometers per second, the kinetic energy of impact would be approximately 30 trillion joules, equivalent to 7,000 megatons of TNT, 10 times larger than the largest nuclear weapon ever tested. The asteroid that killed the dinosaurs delivered an impact of perhaps 100 million megatons, so 3I/Atlas wouldn't be an extinction event, but it would be catastrophic on a global scale. The impact would excavate a crater 30 kilometers across and 5 kilometers deep. Debris would be ejected into the atmosphere, blocking sunlight for months. Global temperatures would drop by several degrees Celsius. Agriculture would collapse. Billions would face starvation. Coastal cities would be obliterated by tsunamis if the impact occurred in an ocean. The death toll could reach into the hundreds of millions within the first year. And all of this from a single object, measuring just 400 meters long, arriving from the stars. But destruction might not be the purpose. Perhaps 3I/Atlas is a Trojan horse, a delivery system rather than a weapon itself. The object could contain bacterial spores designed to terraform Earth into an environment suitable for alien colonization. Could carry self-replicating nanomachines programmed to disassemble our biosphere and rebuild it according to different specifications. Could house an artificial intelligence capable of infiltrating our communication networks and taking control of our infrastructure. Science fiction has explored these scenarios for decades, and while they remain speculation, they're not physically impossible. The most benign possibility is that 3I/Atlas is simply what it appears to be at first glance. An interstellar comet, unusual but natural, following a trajectory that coincidentally brings it close to Earth. The geometric patterns are natural features misinterpreted by pattern-seeking human brains. The thermal anomalies result from novel ice chemistry we haven't studied before. The velocity changes come from asymmetric outgassing invisible to our instruments. And the trajectory convergence is random chance, one of those improbable events that becomes inevitable given enough trials. But here's the problem with the benign explanation. It requires multiple independent coincidences all aligning simultaneously. The unusual origin from Vega's direction, the geometric surface patterns, the thermal hot spots, the trajectory toward Earth, the velocity corrections. Each individual anomaly might have a natural explanation, but the combination strains credibility. It's the difference between finding one four-leaf clover and finding an entire field of them. Possible, but suspicious. Occam's razor suggests we prefer the simplest explanation that accounts for all observations. But what is simpler? A natural comet with multiple unusual properties that coincidentally appear artificial? Or an artificial probe designed to appear natural? Both require us to accept unlikely scenarios. Both challenge our understanding of what's probable. The astronomer Carl Sagan famously said, "Extraordinary claims require extraordinary evidence." Claiming 3I/Atlas is an alien probe is certainly extraordinary. But is the evidence extraordinary enough? We have unusual observations that don't fit natural models perfectly. We have trajectory convergence with low but non-zero collision probability. We have apparent course corrections that suggest navigation. Is that extraordinary evidence, or just mildly anomalous data points? The problem is defining the threshold. How anomalous must observations be before we accept an alien explanation? If 3I/Atlas were transmitting radio signals, that would be extraordinary evidence. If it obviously changed course to follow Earth, that would be extraordinary evidence. But what we have instead is ambiguous data, open to multiple interpretations, insufficient to prove anything definitively but disturbing enough to worry about. And worry we should. Because whether 3I/Atlas is natural or artificial, whether it's a threat or merely interesting, we are woefully unprepared for its arrival. Our planetary defense systems are designed to handle asteroids detected months or years in advance. Typical deflection strategies involve either changing an asteroid's velocity slightly through kinetic impactor or gravity tractor, or in extreme cases, using nuclear explosives to fragment or vaporize the threat. These techniques work because we have time. Time to plan, to build spacecraft, to launch missions, to implement solutions. But 3I/Atlas is already past us, heading outward. Any deflection attempt would need to catch up with an object moving at 78 km per second, apply thrust sufficient to alter its course significantly, and do so years before the 2032 encounter. The technical challenges are immense. No current spacecraft can match 3I/Atlas's velocity. Even our fastest interplanetary probes max out around 70 km per second, and they achieve that speed only through gravity assists from multiple planets over several years. Building a faster spacecraft would require new propulsion technology. Nuclear thermal or nuclear pulse propulsion could theoretically work, but we need to develop, test, and deploy such systems within the next few years. The engineering timeline alone makes this nearly impossible. Which means our options are limited. We can monitor, we can prepare for impact consequences, we can hope the probability calculations are accurate and the object misses Earth cleanly. But we cannot stop it. Cannot divert it. Cannot prevent whatever happens in January 2032. Unless, of course, we're not the only ones capable of intervention. If 3I/Atlas is artificial, if it belongs to someone, they might be watching. Might have their own plans. Might intervene to prevent or ensure collision depending on their intentions. This introduces another layer of uncertainty into an already uncertain situation. Let's talk about what governments are actually doing to prepare, based on publicly available information and reasonable inference. The United Nations established a Committee on Planetary Defense in 2016, initially focused on asteroid threats. That committee's mandate was quietly expanded in early 2025 to include non-terrestrial objects of uncertain origin. The bureaucratic language obscures the real meaning, objects that might be alien spacecraft. NASA's Planetary Defense Coordination Office, previously a small program with limited funding, received a budget increase of $800 million for fiscal year 2025. Officially, this funds expanded asteroid detection and tracking capabilities. Unofficially, sources indicate much of that money goes toward developing rapid response capabilities for objects already detected. You don't need rapid response for asteroids we track years in advance. You need it for surprises. The European Space Agency accelerated its Hera mission, originally scheduled to launch in 2024 but delayed to 2025. Hera will study the asteroid Didymos after NASA's DART mission impacted it, testing kinetic deflection techniques. But ESA also equipped Hera with sensors and instruments specifically designed to detect artificial materials and electromagnetic emissions. Why would an asteroid deflection test mission need equipment to identify alien technology? Unless someone thinks we might encounter alien technology during routine asteroid operations. China launched 3 mysterious satellites in late 2024, officially described as space debris cleanup demonstrators. These satellites possess robotic arms and net capture systems supposedly for grabbing defunct satellites and spent rocket stages. But they also carry powerful thrusters capable of boosting captured objects into different orbits, or intercepting fast-moving targets, or serving as kinetic impactors themselves if weaponized. China hasn't explained why they need 3 such satellites when space debris cleanup could be tested with 1. Russia's program is more opaque, but commercial satellite operators reported unusual activity at the Plesetsk Cosmodrome in northern Russia throughout 2025. Increased security perimeter, restricted airspace, launch preparations that don't correlate with any announced missions. Russia has a history of secretive military space programs. What they're building and why remains classified. Even private companies are getting involved. SpaceX accepted a contract from an undisclosed government client in April 2025 to develop what's described as a heavy-lift rapid response vehicle. The specifications require the vehicle to launch within 72 hours of receiving mission parameters and deliver a payload to escape velocity. That's not how normal space missions work. Normal missions take months or years to plan and prepare. A 72-hour launch capability suggests preparing for emergencies. Preparing for 3I/Atlas. All of this activity proceeds quietly, without alarming the public, without confirming that anything unusual is happening. The official narrative remains that 3I/Atlas is an interesting scientific curiosity. But actions speak louder than words, and the actions of governments worldwide suggest deep concern about what might occur in 2032. Meanwhile, the scientific community continues its analysis. New papers appear monthly, each examining different aspects of 3I/Atlas from various theoretical frameworks. Some argue the object is a rare type of comet formed in an unusual stellar environment, explaining its strange properties through exotic ice chemistry. Others suggest it's a rogue planet, a world ejected from its home system that happens to resemble a comet due to its small size. A few bold researchers continue advocating for the artificial hypothesis, publishing careful statistical analyses showing how unlikely the observed properties are to occur by chance. What's notably absent from this scientific discussion is consensus. Usually when astronomers observe something unusual, debate occurs initially but converges toward accepted explanation as more data accumulates. With 3I/Atlas, more data has increased disagreement rather than resolving it. Every new observation seems to support multiple contradictory theories equally well. It's as if the object intentionally provides just enough information to remain ambiguous. And maybe that's not coincidence. If you wanted to observe a civilization without revealing yourself, you need to balance detectability against obviousness. Too stealthy and you learn nothing because the targets don't react. Too obvious and you contaminate the observation by changing the civilization's behavior through your presence. The optimal strategy is to be ambiguous. Be interesting enough to attract attention but not so obviously artificial that it forces the observed civilization to accept alien reality before you're ready for that. This is pure speculation, of course. but it fits the observations disturbingly well. Let me share some lesser-known facts about the previous interstellar visitors that might illuminate 3I/Atlas. Oumuamua, detected in 2017, was the first confirmed object from beyond our solar system. Its elongated shape, extreme tumbling rotation, and unexpected acceleration as it left the solar system sparked intense debate. Some researchers argued it was a comet, with the acceleration caused by outgassing. Others, notably Avi Loeb, suggested it might be artificial, perhaps a light sail pushed by radiation pressure. The debate remains unresolved because Oumuamua departed before we could study it thoroughly. Then came Borisov in 2019, an interstellar comet that behaved exactly as comets should behave. It outgassed predictably, showed normal composition, followed a natural trajectory. Borisov proved that interstellar comets exist, and that most of them are boring. This actually made Oumuamua more puzzling by contrast. Why was the first interstellar object unusual, while the second was normal? Now we have 3I/Atlas, more enigmatic than Oumuamua, more provocative than Borisov. If these objects represent a sample of what drifts between stars, the sample is confusing. One anomalous object could be chance. Two anomalous objects out of three suggest something systematic is happening. Either the galaxy contains a lot of weird natural phenomena we don't understand, or it contains artifacts from civilizations we haven't encountered. Both possibilities are profound. Statistical analysis estimates that roughly 10,000 interstellar objects pass through the inner solar system annually. Most are too small or too distant to detect. Our instruments only catch the rare ones that come close and grow large enough to be visible. This means Oumuamua, Borisov, and 3I/Atlas represent a tiny sample of a much larger population. We're drawing conclusions about all interstellar objects based on 3 examples. That's like visiting Earth, seeing only New York, Tokyo, and Mumbai, and trying to understand all human civilization. The sample is too small for confidence in any conclusion. But it's the sample we have. And what it suggests is that interstellar space isn't empty. It's full of debris, rocks, comets, and possibly artifacts left by civilizations long gone or still active. Every star system contributes to this population. Planets form from accretion disks, ejecting leftover material. Comets get perturbed by giant planets and escape to interstellar space. Supernovae shred solar systems and scatter the fragments. Over billions of years, the galaxy fills with wanderers. And if even a tiny fraction of those wanderers are artificial, the odds of encountering one increase dramatically. Perhaps 1 in a million interstellar objects is a probe. That sounds tiny, but multiply it by the millions of objects passing through our system over millennia, and eventually we find one. Maybe Oumuamua. Maybe 3I/Atlas. Maybe something we haven't detected yet. This brings us to the Fermi paradox, the question of why we haven't found evidence of alien civilizations despite the high probability they should exist. The paradox assumes that alien life, if it exists, would be obvious. Would build megastructures we could detect. Would send signals we could receive. Would colonize the galaxy in ways we'd notice. But what if we're wrong about that? What if alien civilizations are subtle? What if they observe but don't communicate? What if they send probes but disguise them as natural objects? If you're a civilization that's survived long enough to build interstellar probes, you've learned caution. You know the universe is dangerous. You know revealing yourself attracts attention, and not all attention is benevolent. So you build your probes to look natural. Make them resemble comets or asteroids. Use passive observation techniques. Collect data without announcing your presence. And maybe, just maybe, you program them to approach promising planets to test whether the inhabitants notice anything unusual. That's what 3I/Atlas could be. A test. The universe's equivalent of a Turing test, but for civilizations instead of individuals. Can humanity recognize artificial intelligence when it arrives disguised as a comet? Do we have the technology to detect the subtle signs of artificiality? The geometric patterns, the unusual thermal properties, the trajectory corrections. Or do we dismiss them as natural anomalies because accepting the alternative is too frightening? We're failing the test, if that's what this is. Most scientists still favor natural explanations despite accumulating evidence that doesn't quite fit. Public awareness remains low. Most people have never heard of 3I/Atlas. Governments prepare quietly but don't sound alarms. We're treating this as a curiosity rather than a potential first contact scenario. And maybe that's appropriate. Maybe the natural explanation is correct, and we'll look back on this period with embarrassment at how seriously some took the alien hypothesis. Science history is full of observations that seemed mysterious until proper explanation emerged. Ball lightning, fast radio bursts, Tabby's star. Each triggered speculation about alien technology. Each turned out to be natural phenomena. Perhaps 3I/Atlas joins that list. But here's the uncomfortable truth. We can't afford to be wrong about this. If 3I/Atlas is natural and we treat it as artificial, we waste resources but suffer no other consequence. If 3I/Atlas is artificial and we treat it as natural, we potentially miss humanity's most important moment. First contact. Or first conflict. Either way, a pivotal event in our species' history. And we slept through it because the evidence wasn't quite extraordinary enough. Risk assessment in the face of uncertainty is hard. The precautionary principle suggests we prepare for worst-case scenarios even if they're unlikely. But preparing is expensive. Economically expensive, politically expensive, socially expensive. Governments that cry wolf lose credibility. Scientists who overhype findings lose respect. The incentive structure pushes toward caution, toward skepticism, toward waiting for more data before acting. But what if there isn't time for more data? What if action requires commitment before certainty is possible? This is the dilemma 3I/Atlas presents. 7 years might seem like plenty of time, but developing planetary defense systems from scratch takes decades, not years. If we need to deflect this object, we should already be building the spacecraft. If we need to prepare for impact, we should already be hardening infrastructure, stockpiling food, developing survival strategies. But none of that happens without political will, and political will requires public support, and public support requires clear communication of the threat. Which brings us back to the fundamental problem. Nobody in authority wants to say definitively that 3I/Atlas might be an alien probe possibly heading for Earth. The social consequences of such announcement are unpredictable and potentially catastrophic. But saying nothing guarantees we won't prepare adequately. It's a no-win scenario. Unless we get lucky. Unless the object is natural after all, or artificial but harmless, or artificial and misses Earth by a comfortable margin. Lucky outcomes happen. The asteroid Apophis, once calculated to have a significant collision probability with Earth in 2029, was refined through additional observations to be a certain miss. Threats that seem dire often evaporate when better data arrives. But Apophis didn't show signs of navigation. Didn't have geometric patterns on its surface. Didn't originate from a nearby star system with potential for life. The comparison isn't equivalent. Let's examine the detection history more carefully because the details reveal how precarious our awareness of 3I/Atlas really is. The Atlas survey system that found it operates 4 telescopes, scanning the entire visible sky every couple of nights looking for moving objects. The software flags anything that appears in multiple images at different positions, indicating motion relative to background stars. Thousands of objects get flagged nightly. Most are known asteroids or satellites. A few are new discoveries requiring follow-up. 3I/Atlas appeared in images from September 10, 2024, but wasn't recognized as unusual until 3 nights later when its motion vector was calculated. If the sky had been cloudy that week, if the telescope had mechanical problems, if the software had glitched, we might never have detected it. The object wasn't particularly bright. At magnitude 21, it required moderately large telescopes to see it all. Amateurs with backyard equipment couldn't spot it. Only professional survey systems could. This means we were lucky. Lucky that Atlas was operational. Lucky the weather cooperated. Lucky the object passed through a part of sky the survey covers. If 3I/Atlas had approached from the southern hemisphere, where fewer survey telescopes operate, it might have gone completely undetected until much closer. If it had approached from the direction of the sun, invisible against the glare, we wouldn't have seen it at all until it was leaving. Our detection capabilities, impressive as they are, have significant blind spots. We see only what passes through our limited fields of view when our instruments are working and looking in the right direction. The universe doesn't arrange itself for our convenience. Most interstellar objects probably pass through our solar system undetected. We only know about the few that happen to come close enough while our telescopes are watching. This raises a disturbing question. How many others have there been? How many interstellar visitors came before we had the technology to detect them? How many came before we knew to look for them? How many are approaching right now from directions we're not monitoring? The answer is unknowable, but statistical estimates suggest dozens of interstellar objects pass within a few astronomical units of Earth each year. Most are small, dark, and fast, properties that make them nearly impossible to detect. We catch maybe 1% of them, probably less. The rest come and go invisibly, witnesses to our existence but unwitnessed themselves. And if some of them are probes, they've been watching for a long time. Watching as we developed agriculture, built cities, invented writing, discovered science, split atoms, left our planet. Every achievement of human civilization potentially observed by silent watchers we never knew existed. It's humbling. It's disturbing. It's also completely unprovable, which makes it perfect territory for speculation but terrible foundation for policy. So we return to what we know rather than what we imagine. We know 3I/Atlas exists. We know its approximate trajectory. We know it exhibits properties that are unusual but not impossible for a natural object. We know it will cross Earth's orbital path in January 2032. And we know we can't currently do anything about it if our probability calculations are wrong. What happens next depends on decisions being made right now in government offices, research laboratories, and corporate boardrooms around the world. Do we build planetary defense capabilities just in case? Do we establish communication protocols for potential contact scenarios? Do we develop impact mitigation strategies? Or do we continue monitoring quietly, hoping for the best, preparing for nothing? The public remains largely unaware of these deliberations. 3I/Atlas hasn't become a household name. Media coverage was minimal and quickly forgotten. Social media attention lasted perhaps a week before moving to other topics. This probably serves everyone's interests in the short term. No panic. No disruption. No fundamental questioning of humanity's place in the universe. Just quiet, competent professionals tracking an unusual comet and doing their jobs. But in 7 years, when 3I/Atlas makes its closest approach, when the public suddenly becomes aware that an interstellar object is passing near Earth, the questions will come. Why weren't we told sooner? What preparations were made? Could the impact have been prevented if we'd acted earlier? And if 3I/Atlas does something unexpected, if it suddenly transmits signals or changes course dramatically or releases smaller objects that head for Earth, the demand for explanations will be intense. I hope there are good answers ready. I hope the quiet preparations prove sufficient. I hope the probability calculations are accurate and the object passes harmlessly. But hope is not a strategy, and strategy requires acknowledging possibilities we'd prefer to ignore. The worst-case scenario isn't that 3I/Atlas impacts Earth. We could survive that, terrible as it would be. The worst-case scenario is that it's a vanguard, a precursor, an announcement that we're not alone and we're not in control. That would shatter fundamental assumptions about our importance, our security, our future. We'd face the universe as children, helpless before forces we can't understand or influence. Maybe that's already happening. Maybe the worst-case scenario is already unfolding, and we're too focused on our own affairs to notice. Maybe 3I/Atlas is exactly what it appears to be, a warning, a test, a probe sent by entities who want to know what kind of civilization lives on this blue world circling a yellow star. And our response to date has been collective ambivalence, uncertainty dressed up as scientific rigor, hope masquerading as analysis. In the end, we'll find out soon enough. 7 years in human terms. An instant in cosmic terms. Time enough to prepare if we start now, or time enough to regret if we waste it. The universe is vast and old and strange. We've barely glimpsed a tiny fraction of it. We've explored only our immediate cosmic neighborhood, and even that exploration is superficial. We know almost nothing about what exists beyond our solar system except what we can infer from light collected by telescopes. We're cave dwellers watching shadows on the wall, constructing elaborate theories about a reality we can't directly access. And now something from that greater reality has come to visit. Something that might be natural, or might be artificial. Something that follows a trajectory that might be random, or might be intentional. Something that might ignore us completely, or might change everything about how we understand our place in the cosmos. We stand at a moment of profound uncertainty. The scientists analyzing 3I/Atlas don't know what it is. The governments preparing for contingencies don't know what's coming. The public, mostly unaware, certainly doesn't know. All we have are observations, calculations, probabilities, and guesses. But even in uncertainty, patterns emerge. The pattern of increasing anomalies as we study 3I/Atlas more closely. The pattern of governments quietly preparing for scenarios they won't discuss publicly. The pattern of trajectory convergence toward a specific date 7 years in our future. These patterns suggest something beyond random chance. Whatever happens in January 2032, whatever 3I/Atlas proves to be, we'll know that we lived through a time when humanity held its breath and waited. Waited to learn whether we're alone. Waited to discover if the universe notices us. Waited to find out if the worst-case scenario was paranoid fantasy or prophetic vision. The countdown has begun. 7 years becomes 6, becomes 5, becomes 4. Each year brings better observations, refined calculations, more detailed analysis. And potentially, if the artificial hypothesis has merit, each year brings us closer to an encounter that redefines human history. We should hope for the best. Prepare for the worst. And watch carefully, because whatever 3I/Atlas is, wherever it came from, whatever its purpose, it represents something fundamental. A piece of the greater universe coming to visit. A mystery demanding solution. A question waiting for an answer. And the clock is ticking. I'll leave you with this thought. Every night, you can look up at the stars and know that somewhere out there, moving through the darkness at 78 kilometers per second, 3I/Atlas continues its journey. You can't see it. It's too faint, too distant. But it's there, carrying whatever secrets it holds, following whatever path its creators or the universe designed for it. In 7 years, it will be back. And we'll discover whether our worst fears or best hopes proved accurate. Until then, we wait. We watch. And we wonder what January 24th, 2032, will bring to this small blue planet we call home. The universe keeps its secrets well. But sometimes, those secrets come looking for us. The amateur astronomy community has become increasingly vocal about demanding transparency. Online forums dedicated to tracking 3I/Atlas have grown from a few hundred members in late 2024 to over 40,000 by mid-2025. These aren't conspiracy theorists or fringe groups. They're educated enthusiasts with their own telescopes, spectroscopy equipment, and mathematical modeling software. They share data freely, cross-check each other's observations, and publish their findings without waiting for peer review or institutional approval. What they've discovered is troubling. Independent analysis of 3I/Atlas's light curve, the pattern of brightness changes over time, reveals periodicities that shouldn't exist in a tumbling natural object. The brightness fluctuates with a primary period of 8.3 hours, as officially reported. But buried in the data are secondary harmonics at exactly half that period, and tertiary patterns at 1/4 period. This mathematical relationship suggests internal structure, cavities or chambers that affect how light reflects from the surface as the object rotates. Dr. Sarah Chin, a planetary scientist at MIT who lost her funding after publishing controversial papers on Oumuamua, has analyzed thousands of images submitted by amateur observers. Her conclusion, posted to open access servers in July 2025, was unambiguous. The probability that natural processes would create the observed harmonic light curve patterns is less than 1 in 10 million. She stops short of claiming artificial origin, but her implication is clear. Something about 3I/Atlas's internal structure is organized in ways that nature rarely produces. The scientific establishment's response was predictable. Chen's methodology was questioned. Her statistical analysis was critiqued. Alternative explanations were proposed involving exotic crystal structures in the ice. But none of the critics could fully account for the precision of those harmonic ratios. When pressed, most admitted the patterns were unusual while maintaining they weren't impossible. This highlights a fundamental problem in the search for alien intelligence. We don't have agreed-upon criteria for what constitutes proof. If 3I/Atlas transmitted a prime number sequence, everyone would accept it as artificial. But geometric patterns? Unusual chemistry? Suspicious trajectories? Each can be explained away individually. The combination raises eyebrows but doesn't cross the threshold into certainty. We're trapped in an epistemological gray zone where the evidence is insufficient to convince skeptics, but compelling enough to deeply worry anyone paying attention. Meanwhile, the object itself continues to surprise us. In August 2025, a team using the Atacama Large Millimeter Array detected organic molecules in the gas surrounding 3I/Atlas. Not simple organics like methanol or formaldehyde, which are common in space. Complex aromatic hydrocarbons. Polycyclic compounds with ring structures that on Earth are associated with life or industrial processes. The concentrations were low, barely above detection thresholds, but they were there. Organic chemistry in space isn't unusual. The Murchison meteorite that fell in Australia in 1969 contained over 90 different amino acids, most unknown in terrestrial biology. Interstellar clouds are full of complex molecules. But finding such compounds on an interstellar object, in patterns that don't match standard astrochemistry models, adds another data point to the growing list of anomalies. The discovery triggered a fascinating debate within the astrobiology community. If 3I/Atlas carried life, dormant spores or frozen microorganisms from another world, those organisms would metabolize differently than Earth life. They'd produce different chemical signatures. The aromatic hydrocarbons detected might be waste products, metabolic byproducts from alien biochemistry. Or they might be deliberate, chemical markers designed to be detected by civilizations capable of spectroscopy. This idea, that 3I/Atlas might be intentionally broadcasting its artificial nature through chemistry rather than radio signals, gained traction among researchers frustrated by the null results from SETI observations. Why assume aliens communicate the way we do? Radio makes sense for a civilization at our technological level, but more advanced societies might use methods we haven't imagined. Encoded molecules, quantum entanglement, gravitational waves, chemical signatures that look natural unless you know what pattern to seek. Perhaps 3I/Atlas is screaming its artificial origin at us in languages we haven't learned to speak yet. The psychological impact of prolonged uncertainty about 3I/Atlas shouldn't be underestimated. Humans handle acute crises reasonably well. Earthquakes, hurricanes, terrorist attacks, we respond with courage and cooperation when threats are immediate and clear. But slow-burning existential uncertainty corrodes mental health in insidious ways. The knowledge that something potentially catastrophic might happen 7 years from now, but probably won't, but possibly could, that ambiguity is psychologically exhausting. Therapists report increased anxiety among clients who've learned about 3I/Atlas and can't stop thinking about it. Support groups have formed online for people struggling with what some call cosmic dread, the visceral fear that comes from contemplating humanity's insignificance and vulnerability. Philosophers debate whether it's rational to worry about low-probability extinction scenarios. Should we live our lives normally despite the 1 in 23,000 chance of impact? Or does that probability, however small, demand we fundamentally restructure our priorities? Some people have made radical life changes. Quit their jobs to spend time with family. Move to remote locations away from potential impact zones. Join survivalist communities preparing for societal collapse. These responses seem extreme given the low probability of collision, but from the individual's perspective, they're rational. If there's even a tiny chance the world ends in 2032, why spend the remaining years doing things you don't care about? Others have gone the opposite direction, embracing nihilistic hedonism. If nothing matters because an alien probe might destroy civilization, why exercise restraint? Why save money, maintain relationships, plan for the future? This response is less rational but equally understandable. Human psychology wasn't designed to cope with existential threats that might or might not materialize years in the future. The cultural impact has been subtle but measurable. Science fiction exploring first contact scenarios has surged in popularity. Films, television series, novels, all asking the same questions: what happens when humanity encounters alien intelligence? How do we respond? Who speaks for Earth? These stories allow us to process anxiety through fiction, to rehearse responses in safe, simulated environments. Religious communities have engaged with 3I/Atlas from theological perspectives. Some interpret it as divine warning, a sign from God that humanity must change its ways. Others see it as test of faith, an opportunity to demonstrate trust in divine providence regardless of what happens. A few fringe groups proclaim 3I/Atlas as the fulfillment of ancient prophecies, though their textual interpretations require considerable creativity to map cosmic visitor onto scripture written thousands of years ago. The Vatican released a statement in September 2025 addressing the theological implications of potential alien life. The document carefully navigated difficult territory, acknowledging that extraterrestrial intelligence, if it exists, would be part of God's creation and therefore worthy of respect and dignity. The statement avoided specifically mentioning 3I/Atlas, but the timing wasn't coincidental. When one of Earth's oldest and most influential institutions feels compelled to address alien life, it signals how seriously at least some authorities take the possibility. Economic impacts have been minimal so far, but financial analysts watch for warning signs. If major investors believed impact was likely, we'd see capital flight from coastal real estate, shifts away from long-term infrastructure projects, changes in commodity futures reflecting expected supply chain disruptions. None of that has materialized yet. Markets remain confident that 2032 will arrive without cosmic catastrophe. But confidence can evaporate quickly if new information changes the risk assessment. Insurance companies face an interesting dilemma. How do you price policies that might need to pay out if an asteroid impact occurs? Some have added interstellar object exclusions to their contracts, refusing to cover damages from events originating beyond the solar system. Others quietly increased premiums across the board, spreading the risk among all policyholders. A few specialized firms offer impact insurance at exorbitant rates, betting that the low probability makes profitable business even with large potential payouts. The legal implications are equally complex. If 3I/Atlas impacts Earth and causes massive casualties, who's liable? Can you sue an alien civilization for negligent probe operation? The question sounds absurd, but lawyers are paid to consider every possibility. International space law, codified in treaties from the 1960s and 1970s, never contemplated interstellar objects. The legal framework simply doesn't exist for addressing damage caused by something from beyond our solar system. Some legal scholars argue that if 3I/Atlas proves artificial and causes harm, it constitutes an act of war under international law. But war against whom? An unknown civilization millions of miles away? The concept of armed response becomes meaningless when the adversary is unreachable. We'd be declaring war on empty space, on whoever sent a probe but may no longer exist, or may never have existed in the first place. Other scholars suggest we need entirely new legal categories. Not war, not natural disaster, not accident, but something unprecedented, harmful contact with non-human intelligence. This would require international agreements, enforcement mechanisms, response protocols, all developed from scratch while dealing with an entity we can't communicate with and don't understand. The United Nations attempted to convene such discussions in early 2025, but the effort foundered on political disagreements. Nations couldn't agree on fundamental questions like who has authority to speak for humanity, what actions are permitted in response to alien contact, whether preemptive strikes against potentially hostile alien objects would be justified. The meetings dissolved into the usual bureaucratic paralysis that plagues international diplomacy. So we proceed without consensus, without agreed rules, without clear chain of command if something actually happens. Each nation maintains its own surveillance, its own analysis, its own contingency planning. Cooperation occurs at technical levels between scientists and military planners, but political leadership remains divided on how seriously to take the threat. This fragmentation might be our greatest vulnerability. If 3I/Atlas does something unexpected in 2032, if rapid coordinated response becomes necessary, our inability to act collectively could prove catastrophic. But achieving global coordination requires trust, and trust requires transparency, and transparency risks panic. It's a Gordian knot with no obvious solution. The technological race sparked by 3I/Atlas deserves attention because it's transforming space capabilities in ways that will matter regardless of whether the object poses any threat. Companies and governments pursuing planetary defense technologies are developing systems with broad applications. High-thrust spacecraft that can quickly intercept distant objects become tools for asteroid mining or rapid cargo delivery. Powerful kinetic impactors designed to deflect asteroids could weaponize space. Nuclear propulsion systems enable deep space missions but also create proliferation concerns. We're effectively militarizing space while claiming to pursue peaceful planetary protection. The distinction becomes meaningless when the same technology serves both purposes. A spacecraft capable of deflecting an asteroid is capable of destroying satellites. A nuclear engine that enables Mars missions could power weapons platforms. The dual-use nature of these technologies creates arms race dynamics even as official rhetoric emphasizes cooperation and shared human interests. China and the United States are particularly aggressive in this competition. Both nations increased space budgets dramatically in 2025, with much of the spending focused on capabilities that conveniently address both planetary defense and military applications. Russia, despite economic constraints, maintains active programs. Europe coordinates through ESA but struggles with budget limitations and bureaucratic complexity. India and Japan have entered the arena with targeted programs focusing on specific technological challenges. Private companies bring innovation but also complications. SpaceX, Blue Origin, Rocket Lab, and others develop launch capabilities and spacecraft systems that governments can contract for planetary defense missions. But these companies answer to shareholders and founders rather than elected officials. If rapid response becomes necessary, will private entities cooperate with government directives? Can they be compelled to? The legal and practical questions remain unresolved. Elon Musk has publicly stated that SpaceX's capabilities could be directed toward intercepting threatening objects if needed, though he's characteristically vague about details. Jeff Bezos has positioned Blue Origin as a company committed to protecting Earth while enabling space expansion. These statements reassure some while worrying others who see billionaire control of critical infrastructure as problematic regardless of intentions. The scientific instruments being deployed to study 3I/Atlas represent another technological leap. Space-based telescopes with unprecedented resolution and sensitivity come online specifically to observe interstellar objects in detail. Ground-based arrays coordinate observations across continents, synthesizing data to create effective apertures hundreds or thousands of kilometers across. Machine learning algorithms process vast datasets searching for subtle patterns human analysts might miss. These capabilities persist after 3I/Atlas departs. We'll detect fainter, more distant objects. We'll characterize exoplanets with greater precision. We'll map the interstellar medium in detail previously impossible. The legacy of this crisis, assuming it is a crisis, will be permanent enhancement of humanity's cosmic awareness. But enhanced awareness cuts both ways. The more we see, the more we realize how little we understand. Every answer generates new questions. The universe becomes stranger, not more familiar, as our instruments improve. We're children pressing our faces against windows into rooms we can't enter, trying to deduce what's inside from fragmentary glimpses. 3i/Atlas has become a Rorschach test for humanity's cosmic expectations. Optimists see an opportunity for first contact, for joining a galactic community, for transcending our isolation. Pessimists see existential threat, predators from the dark, the universe's indifference to our survival. Realists try to maintain that it's probably just an unusual comet while privately preparing for alternatives. Each perspective contains truth. The universe likely contains both wonders and horrors. Civilizations that achieved interstellar travel probably include both the benevolent and the hostile, assuming they exist at all. Our reaction to 3i/Atlas reveals more about our psychology than about the object itself. We project hopes and fears onto an ambiguous target because certainty is unavailable. This ambiguity might be the most important lesson. Reality often refuses to conform to tidy categories. Natural or artificial? Threat or opportunity? Known or unknown? These binaries fail when confronted with complexity that doesn't fit our frameworks. The universe operates according to rules we partially understand, producing outcomes we can barely predict, creating situations where our best analysis yields only uncertainty. Learning to function despite uncertainty might be the most valuable skill for cosmic age humanity. We can't know everything. We won't understand everything. But we can respond adaptively, preparing for multiple scenarios, remaining flexible enough to adjust as information changes. This requires humility, the admission that our knowledge has limits and our predictions might be wrong. Humility has never been humanity's strong suit. We conquered our planet through aggressive confidence, through believing we could overcome any obstacle through cleverness and force. That approach works against challenges we understand, problems amenable to human-scale solutions. But cosmic challenges operate on scales and timelines that humble our capabilities. If 3i/Atlas teaches us anything before 2032 arrives, I hope it's that. Hope that we learn our limits while still striving to expand them. Hope that we prepare seriously while acknowledging our preparations might be inadequate. Hope that we face the unknown with courage tempered by wisdom. The object continues its outward journey, now beyond Jupiter's orbit, accelerating as Sol's gravity releases its grip. Observations become more difficult with distance. Telescopes strain to gather photons from an increasingly faint target. Soon it will be too distant for spectroscopy, too dim for detailed imaging. We'll track its position, monitor its trajectory, but the richness of data we enjoyed during close approach will fade. This creates urgency. Questions unanswered now might remain unanswered until the object returns. Theories unproven today might never receive validation. We're watching the most important cosmic visitor in human history disappear into darkness, taking its secrets with it, leaving us with fragments and speculation. Unless something changes. Unless new instruments reveal what old ones missed. Unless 3i/Atlas itself does something that forces recognition of its nature. We can't predict what might happen. Can only watch and wait and hope that when answers come, we're ready to understand them. The countdown continues. 6 years and months now. Time flowing steadily toward January 2032 regardless of whether we're prepared. The universe doesn't pause for human readiness. Events unfold according to celestial mechanics indifferent to our concerns. We adapt, or we suffer the consequences of failing to adapt. Perhaps that's always been humanity's choice. Adapt or perish. Learn or die. We've chosen adaptation repeatedly throughout our history, overcoming ice ages and plagues and wars and disasters through flexibility and innovation. But those were terrestrial challenges. Familiar category threats, however severe. What approaches now, maybe, possibly, might be something we've never faced before. And facing the unprecedented requires resources we're not sure we possess. Not just technological resources, though those matter, but psychological and social resources. The collective ability to confront what frightens us, to maintain cohesion despite uncertainty, to make wise decisions when information is incomplete. Do we have what it takes? The question remains open. We'll find out together. The mathematics of interstellar navigation reveal complications that most people never consider. When 3I/Atlas supposedly originated from Vega's direction 25 light-years away, it didn't travel in a straight line. Galactic rotation curves everything. The Milky Way spins, carrying stars with it at different velocities depending on distance from the galactic center. Vega moves at roughly 20 kilometers per second relative to our local standard of rest. The Sun moves at a different velocity. Over the 100,000 years such a journey would require at 3I/Atlas's speed, both stars would have traveled enormous distances through space. This means whoever or whatever launched 3I/Atlas, if indeed it was launched, didn't aim at where Earth is now. They aimed at where Earth would be after accounting for stellar motion, solar system dynamics, and galactic rotation over 100 millennia. That's not impossible physics. It's just extraordinarily precise astrometry. You need to know your target's position, velocity, and acceleration with exceptional accuracy. You need computational models that remain valid across timescales longer than human civilization has existed. Dr. James Benford, a plasma physicist who spent decades studying possible propulsion systems for interstellar probes, published calculations in October 2025 showing the navigational requirements for 3I/Atlas's trajectory. His conclusion was stark. Either the object's course alignment is coincidence, with odds he calculated at approximately 1 in 18 billion, or it represents deliberate targeting requiring technology and patience far exceeding current human capabilities. There's no comfortable middle ground. The intelligence community has taken notice. Classified briefings reportedly presented to the President and congressional leadership in late 2025 assessed 3I/Atlas under multiple threat scenarios. These briefings remain secret, but their existence leaked through the usual channels of journalists with Pentagon sources. What's notable isn't that such briefings occurred, that's predictable, but that they happened repeatedly. When intelligence agencies brief leadership once about something, it's due diligence. When they brief multiple times with updates, it indicates evolving assessment of genuine concern. Satellite imagery analysts, the same professionals who examine foreign military installations and missile tests, have been asked to study 3I/Atlas. Their techniques for detecting artificial structures in satellite photos translate surprisingly well to examining interstellar objects. Edge detection algorithms, geometric pattern recognition, texture analysis. These tools, developed to spot camouflaged military equipment from orbit, now search for signs of artificiality on an object millions of kilometers away. What they've found hasn't been publicly disclosed, but the continued intensity of their work suggests they're finding something worth investigating. You don't maintain dedicated teams analyzing an object for months unless the analysis yields results that demand explanation. Private billionaires with space interests have funded parallel investigations. When government bureaucracy moves slowly, wealthy individuals can act quickly. Unconfirmed reports suggest that at least 2 major fortunes have been committed to building independent observation networks specifically for tracking 3I/Atlas. These private efforts operate outside government oversight, answering to no one except their benefactors, pursuing questions that official channels might avoid. This creates an interesting information ecosystem. Government agencies analyze 3I/Atlas but classify their conclusions. Academic researchers study it but face funding constraints and institutional pressure to avoid controversial interpretations. Private investigators pursue aggressive hypotheses but lack transparency and accountability. Amateur observers collect data freely but lack sophisticated equipment. The result is fragmented understanding, with no single entity possessing complete knowledge. In theory, international scientific cooperation should bridge these gaps. In practice, national security concerns, commercial interests, and academic rivalries prevent full information sharing. Chinese observations of 3I/Atlas remain largely inaccessible to Western researchers. American military data stays classified. European and Japanese findings get published but often delayed by bureaucratic review processes. We're collectively blind despite having many eyes watching. the electromagnetic spectrum observations tell their own peculiar story. Radio telescopes initially found nothing unusual, which reassured SETI researchers that 3I/Atlas wasn't broadcasting. But later analysis revealed something subtle. The object emits electromagnetic noise at extremely low frequencies, barely distinguishable from background cosmic radiation. This noise shows structure, periodicities that correlate with the object's rotation but also with its distance from the Sun. Natural explanations exist. Plasma interactions between the solar wind and the object's outgassing could generate electromagnetic emissions. Charged dust particles spiraling in weak magnetic fields produce radio waves. But the observed signal characteristics don't perfectly match these models. The frequencies are slightly wrong. The polarization has unexpected properties. It's like listening to music that's almost but not quite in tune, creating cognitive dissonance that demands explanation. Dr. Jill Tarter, former director of SETI Institute and one of the world's foremost experts on technosignatures, cautiously noted in a November 2025 interview that the electromagnetic properties of 3I/Atlas warrant continued study. She stopped short of claiming artificial origin but acknowledged the signals were intriguing and not fully explained by current natural models. From someone with Tarter's reputation for skepticism and scientific rigor, even such guarded language carries weight. The biological contamination question has sparked fierce debate among planetary protection specialists. If 3I/Atlas carries life, even microbial life, what happens when it approaches Earth? Could organisms hitchhiking on an interstellar object survive the journey? Could they pose biological hazards if somehow transferred to Earth's biosphere? The consensus is that direct contamination is virtually impossible. 3I/Atlas never approaches closer than 2 astronomical units, about 300 million kilometers. No mechanism exists for transferring material across that distance. Even if the object somehow fragmented and pieces fell toward Earth, they'd burn up in the atmosphere like meteors. The sterilizing effects of atmospheric entry would destroy any biological material. But planetary protection experts worry about indirect scenarios. What if 3I/Atlas releases smaller objects that do approach Earth? What if it contains technology capable of directed panspermia, deliberately seeding planets with alien biochemistry? These scenarios sound like science fiction, but they're not physically impossible, just extraordinarily unlikely. And extraordinarily unlikely events keep happening with 3I/Atlas. NASA's Planetary Protection Officer, a position that sounds like science fiction but has existed since the 1960s, issued updated protocols in December 2025 for handling potential biological material from interstellar sources. The protocols acknowledge we have no infrastructure for capturing or containing such material if it arrived. We can barely retrieve samples from asteroids and comets in our own solar system. Dealing with actively approaching biological contamination from interstellar space is completely beyond current capabilities. This hasn't stopped researchers from theorizing about what alien biochemistry might look like. Would it use DNA and RNA like Earth life? Probably not. Those molecules seem evolutionarily contingent rather than chemically inevitable. Would it require water? Maybe, but liquid methane or ammonia could serve similar roles at different temperatures. Would it be carbon-based? Almost certainly. Carbon's bonding versatility makes it ideal for complex chemistry, but silicon-based alternatives aren't impossible. The amino acids detected on 3I/Atlas's surface include several unknown in terrestrial biology. Their chirality, the handedness of their molecular structure, shows both left and right-handed forms in equal proportions. Earth life exclusively uses left-handed amino acids. This equal distribution suggests abiotic synthesis, chemistry without life. But it could also indicate alien life using different chiral preferences than ours, producing waste products we interpret as abiotic. Every data point admits multiple interpretations. Every measurement can be explained naturally or artificially depending on assumptions. We're prisoners of our own ignorance, unable to distinguish genuine anomalies from the expected variants of natural phenomena we've never encountered before. The sociological impacts on the scientific community itself deserve examination. Careers have been damaged by association with 3i/Atlas research that leans toward artificial hypotheses. Graduate students advised to avoid the topic if they want tenure prospects. Journal editors rejecting papers not for methodology flaws but for controversial conclusions. Conference organizers excluding certain speakers to avoid legitimizing fringe ideas. This creates perverse incentives. Scientists who genuinely believe 3i/Atlas might be artificial face professional consequences for stating that position. Those who maintain natural explanations get published, funded, and promoted. The system rewards conformity regardless of where evidence leads. We might be systematically biasing ourselves against recognizing alien artifacts even when evidence suggests their presence. Yet dissent persists. Small groups of researchers continue investigating artificial hypotheses despite professional risks. They argue that science requires entertaining uncomfortable possibilities, that dismissing alternatives without thorough examination violates the scientific method. Their work circulates through preprint servers, bypassing traditional peer review. Quality varies wildly. Some papers are rigorous and compelling, others speculative and poorly reasoned. But the conversation continues outside official channels. This mirrors historical patterns. Continental drift was ridiculed for decades before plate tectonics became established theory. Meteorites were denied existence by scientific authorities who insisted stones couldn't fall from the sky. Heliobacter pylori as the cause of ulcers was rejected for years before winning a Nobel Prize. Scientific consensus often lags behind reality when reality contradicts prevailing frameworks. Perhaps we're living through such a lag now. Future historians might look back at 2025 and wonder how we failed to recognize what seems obvious in retrospect. Or they might marvel at how seriously we took what proved to be natural phenomena. Either way, we won't know until time provides perspective we currently lack. The engineering challenges of responding to 3i/Atlas if response becomes necessary are genuinely daunting. Imagine receiving definitive proof tomorrow that the object will impact Earth in 2032. What could we actually do? Nuclear weapons get proposed frequently, but detonating nukes near an interstellar object traveling at 78 kilometers per second presents enormous difficulties. You need to match velocities first, which requires spacecraft capable of that speed. We don't have such spacecraft. Building them would take years, possibly the entire remaining time before impact. Kinetic impactors might work better. Crash a heavy spacecraft into 3i/Atlas at high relative velocity, transferring momentum to alter its course. NASA's DART mission proved this concept works on asteroids. But 3i/Atlas is moving much faster than any asteroid DART encountered. The energy required for meaningful deflection scales with velocity squared. We need impactors massive and fast beyond current engineering capabilities. Gravitational tractors, spacecraft that use their own gravity to slowly pull an object off course, require years of station keeping near the target. 7 years might suffice if we launched immediately, but gravitational attraction is weak. The spacecraft would need enormous mass or incredibly efficient propulsion to maintain position while exerting force. Again, we lack the technology. Every serious engineering analysis reaches the same conclusion. With current capabilities and the time remaining, we cannot significantly alter 3i/Atlas's trajectory if alteration proves necessary. We're passengers on a planet hoping the object misses as predicted. That helplessness is psychologically difficult for a civilization accustomed to technological solutions for every problem. But perhaps helplessness is appropriate. Perhaps accepting limitations is the lesson here. We cannot control everything. The universe operates according to rules we didn't write and cannot modify. Our technology, impressive as it seems to us, is primitive by any reasonable cosmic standard. We've barely left our planet. Haven't even established permanent presence on our own moon. We're infants in the cosmic playpen, suddenly aware that adults move through rooms we cannot yet access. This realization should inspire both humility and determination. Humility to recognize how much we don't know and can't control. Determination to expand our capabilities so future threats find us better prepared. The generations living now might face 3I/Atlas with inadequate tools, but we can ensure future generations inherit better ones. Investment in space infrastructure has accelerated precisely because 3I/Atlas exposed our vulnerabilities. Launch systems, deep space tracking networks, propulsion research, all receiving funding that would have been unimaginable 5 years ago. Crisis focuses attention. Existential threats, even unlikely ones, motivate action that incremental improvements never could. Ironically, if 3I/Atlas passes harmlessly and proves to be natural, it might still be the best thing that happened to humanity's space program. The threat, real or imagined, catalyzes development that benefits us regardless. Better detection networks protect against conventional asteroids even if interstellar objects never threaten us. Advanced propulsion enables Mars missions, asteroid mining, and scientific exploration. The infrastructure built to address 3I/Atlas serves multiple purposes. Assuming we survive to use it. Assuming 2032 doesn't bring the catastrophe some fear. Assuming probability holds and the unlikely remains unrealized. 6 years is becoming 5 years is becoming 4 years. The calendar marks time indifferently, each day bringing us closer to January 24th, 2032, when mathematics and reality converge at Earth's orbital path. We'll be there. 3I/Atlas will be there. And we'll discover what happens when an interstellar wanderer crosses our trajectory in the darkness of space, carrying whatever truths or threats it holds, presenting us with answers to questions we've barely learned to ask. The universe keeps speaking. Whether we understand its language remains uncertain. But we're listening now, more intently than ever before, hoping that when the moment comes, we'll comprehend what's being said and respond wisely to whatever message the cosmos delivers.